Today in class, we did a polynomial review. This should all be things that you learned in previous years. A lot of it you learned last year in 10th grade, so hopefully this will just refresh your memory. We're going to start with some terms to know. First of all, the degree of a polynomial. A polynomial has lots of different looks to it, but generally we're talking about a polynomial with only one variable and many of that variable. So like a 2x squared plus 5x minus 7 would be a polynomial. The degree of a polynomial is the greatest exponent of all my terms. So here is a polynomial. It has 5 different terms to it. Can you see the sections? 1, 2, 3, 4, 5. My largest exponent is 4. So this is going to be a 4th degree polynomial. Next, descending order. Descending order is when the terms of a polynomial are listed in order from largest to smallest exponent. So here I have another 5-term polynomial, but it's not written in descending order. So let's take a look at what that would do for us. Notice my term with the greatest exponent is this negative 9x to the 4th. I'm going to write that first and make that largest exponent my first term. My second largest exponent is over here on the negative 5x to the 3rd. So that's going to be written second. My next largest exponent is on that positive 6x squared. Next will come that negative 3x. It has an exponent of 1. Remember, x is the same as x to the first power. And finally, my constant, which has no power at all, is going to be written last. Now I've written this polynomial in descending order. Next, let's talk about leading coefficient. Leading coefficient is the coefficient of the term with the largest power. So if I have my polynomial written in descending order, it's going to be my very first coefficient. So let's take a look. If I have this 3-term second degree polynomial, right, a degree of 2, I'm going to look at the coefficient on that leading term. Since my coefficient is 4, my leading coefficient is 4. Remember, coefficient is defined as the number in front of a variable or the number being multiplied to a variable. Next, we're going to talk about terms, coefficients, variables, and powers. Here I have a polynomial. It is not in descending order, but for now we're going to kind of ignore that. If I have to identify the terms of this polynomial, the terms are basically divided by addition and subtraction signs. The sign in front of a term goes with that term. So the sections of this polynomial are 5x squared. I'm going to separate them by commas. Negative 7x to the 5th, comma, positive 3x to the 4th, comma, negative 6x, comma, and positive 2. These are the 5 terms of the polynomial that I was given. Now, for each term, we're going to identify its coefficient, variable, and power. We're going to start with 5x squared. The coefficient, remember, is the number in front of a variable or being multiplied to a variable, so our coefficient is 5. The variable is x, and the power is 2. On negative 7x to the 5th, coefficient is negative 7, variable is x, and power is 5. On the next term, 3x to the 4th, the coefficient is 3, variable x, power is 4. On negative 6x squared, coefficient is negative 6, variable is x, power is 2. Now, let's talk about our constant down there on the end. Our constant is different than any of our other terms, simply because there's no variable. Since there's no variable, there can't be a coefficient. So with no coefficient and no variable, we're just going to say that it has a power of 0. So let's look at an example. Let's write a polynomial in descending order that contains the 4 given terms. So let's make sure it's in function notation. Descending order, which one would I write first? The 10x to the 5th. Which one would I write second? The positive 4x cubed. Third, the positive x squared. Don't forget that that has a coefficient of 1 even though you can't see it. And finally, our minus x, or minus 1x. There's our polynomial in descending order. Now, what's its degree? Degree, remember, refers to the largest exponent or greatest exponent in my polynomial. So this is going to be a 5th degree polynomial. And its leading coefficient, in other words, the coefficient on that term with highest degree, would be 10. Now let's really quickly go through addition, subtraction, and multiplication of polynomials. Remember, with addition and subtraction, it's simply a matter of combining like terms. When I combine like terms, keep in mind that all I can do is add or subtract coefficients. If I can get this to right, sorry, we're having some technical difficulties. I cannot add or subtract or multiply exponents. It's only the coefficients that get combined. So since that has to happen, remember, like terms need to have identical twin variables and powers. So for instance, 2x squared is an identical twin variable to 7x squared. Those can be combined since they're like terms. All I can do is combine their coefficients. 2 plus 7 gives me 9x squared. Next, I have an x. This x has no identical twin variable, so it just gets included anyway. And then the 10 and the 14, since they're both constants, can be combined to give me a positive 24. This is my simplified addition problem. Next, let's try a subtraction. Subtraction looks a little different when we're subtracting everything in the second set of parentheses. So first thing I'm going to do is distribute that subtraction sign. If I distribute that subtraction sign, this is going to become a negative 12x to the 6th. I'm going to be subtracting 4x to the 5th. I'm subtracting a negative 2x, and what happens when we subtract a negative? It's just like addition, so adding 2x, and finally subtracting 1. Don't forget to distribute that subtraction sign all the way through the second set of parentheses before you start to combine. So now I can take a look at combining. I'm going to take this negative 1x to the 6th. Don't forget there's a 1 there. And I'm going to subtract 12 more x to the 6th. That's going to give me negative 13 x to the 6th power. My next largest exponent is on this negative 4x to the 5th. Since he doesn't have any identical twin variables to combine with, he just gets included anyway. So now I've taken care of those three terms. My next largest exponent comes on this 7x squared. I don't have any other x squared terms, so he just gets included anyway. My next largest exponent is on the positive 2x, and I have no other x terms to combine with. And finally, my two constants, 11 minus 1. This is my simplified subtraction polynomial. And finally, multiplication. Multiplication with polynomials is just like a ginormous distribution problem. Okay? I'm going to take each term in the first polynomial, so in other words, the negative 5x and the positive 2, and I'm going to distribute those to every term in the second polynomial. So to the 3x squared, to the negative x, and to the 4. So we're going to start by distributing negative 5x. Negative times a positive gives me a negative. 5 times 3 gives me 15. And the 1x over here multiplied to the 2x's over here give me x to the 3rd power. Next, I'm going to combine negative 5x to negative x. Negative times a negative gives me a positive. 5 times, remember there's a 1 here, gives me 5. And x times x gives me x to the 2nd power. And I can't forget to combine the negative 5x with the 4. Negative times a positive gives me a negative. 5 times 4 gives me 20. And there's only one x between the two terms. Next, I need to distribute the 2. 2 combined with the positive 3x squared. Positive times a positive is a positive. 2 times 3 gives me 6. And between the two terms, I have x to the 2nd power. Next, positive 2 times negative 1x. Positive times a negative gives me a negative. 2 times 1 gives me 2. And between the two terms, I only have 1x. And finally, 2 times 4 gives me a positive 8. Now I can combine like terms. This x to the 3rd term has no identical twin variables, so it gets included. I have 2x squared terms, 5x squared, and I'm adding 6 more. That gives me 11x squareds. I have negative 20x minus 2 more x's gives me negative 22x. And finally, my constant, positive 8. Here's my simplified polynomial. Just kind of a little helpful hint here. If I have 2 terms in the first polynomial and 3 terms in the second, 2 times 3 gives me 6. When I multiply these together, I should end up with 6 terms before I start combining. If I had 2 terms in the first polynomial and 2 terms in the second, 2 times 2, I should have 4 terms before I start combining. If I had 3 terms and 3 terms, I should have 9 terms before I start combining. Be a little careful so that you can not cut corners when you multiply polynomials. Remember that this video has a rewind and a pause. I would like you to be writing down definitions and examples as you go through these videos. Make sure to write down any questions and come see me during charger time or after school so that you're not lost when we go to our next lesson. Good luck, and I'll see you later.